Hello everyone, my name is Gustavo Camargo, one of the authors of the Farm Energy Analysis tool, which we call FEAT. This tool was developed here at Penn State at the Department of Agriculture and Biological Engineering. I will go through the model and explain how to use it. We are first here at the info workbook, so you can see the information of the worksheets, which includes ag inputs, energy, greenhouse gases, and crop, and also a license information and information about the authors. To illustrate how the model works, I will demonstrate a corn-soybean rotation farm scenario. So we go here to crop workbook. If we minimize here, we see the extent of this workbook. In this corner here are the agronomic outputs, and then here are the energy analysis, here are the greenhouse gas analysis, and over here on the right are the graphs that are generated. So first thing, let's zoom back, let's go up. So here we are in the agronomic inputs. So as you can see, there's all sorts of crops here, totaling 13 crops. So we have barley, corn for silage, rye for silage, wheat, grain, wheat for silage, alfalfa, red clover, canola, soybean, sugar beet, miscanthus, switchgrass, hybrid poplar, and willow. The cells highlighted in blue are the ones that you need to fill in, which are just tillage type, that we have conventional tillage, reduced tillage, or no-till. So you can change numbers as you wish, and you need to put the field area for each crop. So in this case we have 50 hectares of corn and also 50 hectares of soybean. We have a total area of 100 hectares. Then once the field area are filled, you can also change the other inputs, which are yield, crop moisture at harvest, crop moisture at storage, nitrogen fertilizer rate in kilograms per hectare per year, phosphate rates, potash rate, lime, seed rates, herbicide rates, insecticides, diesel fuel consumption, and drying energy and transportation of the inputs. All of these information are already default in here, but if you want to change any of the information, you can just, let's say we are in corn grain here. So let's say we want to change the rate of nitrogen. So we can say, okay, we just use 100. So we change, and the calculations will go from there. Another thing I'd like to mention here is, once you do this, all this done, the calculations are made. So the information go here for the energy analysis, and going down goes to the greenhouse gas analysis and generates the graphs. And also in this corner here, the summary of the crops selected. So we have energy inputs, energy outputs, net energy value, net energy ratio. Also, if you're interested in having crop residue, so in our case we had corn, so we're allowed to have corn stover. We could select the amount of corn stover residue percentage we want to remove, let's say 50%. So once we hit, it started the calculation. I would like to point here, everything you change something, automatically the calculations goes through. So if you could see, there was a shift in calculations here. This is very helpful to have a spreadsheet set up like this. Another point I would like to mention is that the spreadsheet is 100% transparent. What I mean by that, let's say yield for corn. So we go to the cell 7, D7, so then we double click, we see that this comes from ag inputs B3. Yield for soybeans, ag inputs B11. So then you might think, okay, I know where this is coming, so let's go to this B11 workbook. Ag inputs B11. So here we are at ag inputs, and then we go B11, soybean, yield. So this comes from the PSU agronomy guide. Based on our fertilization recommendations, we got that yield. And this applied to all of the others crops. So we have two options of crops. One, yields represented for our region, or we can also use averages. This applies for the agronomic inputs, which is this page that we are right now. You can see we have all of the information, and also in the right we have the reference. Coming back to the crop that we were, this applies also to all the nitrogen rates and everything listed as inputs. Moving to the energy analysis, the calculation is done by getting the information from upper table and multiply by energy workbook B3. Energy B3 is the nitrogen energy content. So let's go energy B3. Here's the mean of the selected publications that publish nitrogen energy requirements to be produced. And this also applies to all of the others inputs, as you can see here in this workbook. And this, you can add them up and divide by the area right here in the left. Going down, we have the greenhouse gas emissions analysis. Similar to the energy analysis, we got the inputs from the agronomic tables up there and multiply it by a parameter of the greenhouse gases, GHG B9. So let's go to GHG and we go B9, and we get an average of nitrogen fertilizer production. Pretty much that's how the spreadsheet works. Very transparent. You can see everything where it is coming from. Finally, all these numbers translate into graphs. So we have two types of graphs. The first is a pie chart of the inputs. So we have the energy inputs, how each input represents in terms of energy, of the overall energy. So we have nitrogen and on-farm fuel use for this scenario that I've created. And also when we scroll down to the GHG total emissions, we get nitrous oxide from nitrogen, and also nitrogen and liming and on-farm fuel use. You can get a sense of how each of the inputs impact in the overall energy and emissions. The second type of graph, it's what's called the energy balance or the greenhouse gas balance, which has inputs, outputs, and a net, which is outputs minus inputs. In this case here, the lower the better. And similarly, we got the energy greenhouse gases. So we got the inputs, outputs, and also the net, which is outputs minus inputs. The more negative, the better. And here on the right hand side, you can see each of the color, what they represent. If we highlight this one here, you can see from Excel that is nitrous oxide, or you can also see from the labeling at the side. This concludes the tutorial for the farm energy analysis tool, FEAT. If you have any questions, you can contact us at feat@psu.edu. Thank you.